I've built this assembly file of a thermos with functioning threads, and I'll be showing you how to recreate this design by utilizing two separate part files. The two part files consist of the body and the lid of the thermos. I'm beginning with the thermos body, and I want you to take a look at all of the features to the left in the feature manager to get an idea of what it takes to actually build this body. I'm rolling back each feature of the design so I can move step by step through each sketch and feature to show you the process of how to build this thermos. I've decided to split the screen here so that you can see the thermos body that I've already built, but also follow along and see how that thermos body is built. So just starting with the body feature, which is a revolved ball space, I've opened up the sketch to see the dimensions and the shape that I created to create the main body of the thermos. So now I'm replicating that over in the new sketch that I've created. Here I'm using the origin as my starting point and drawing just a rectangle and going back to Smart Dimension the measurements. Notice the original thermos design is in IPS units, so I need to change the units of the sketch that I'm working on now, the new part, to IPS. So here I'm just changing up those dimensions to get them the same as the dimensions in the sketch to the left. One of the most important things when drawing a sketch to revolve is to ensure that you have a closed contour sketch, meaning that all points come together completely to create a closed contour shape. After completing the sketch and dimensioning the sketch, I'm going back to the original design and opening up to edit the body, but I'm just looking at it. I'm just looking at that revolved ball space so that you can see the details. So the axis of revolution that I'm going to be selecting for the new sketch is actually that center line. And so in SolidWorks, you can use a center line or you can use a solid line. Center line is also known as a construction line. To create the revolved ball space, I went to Features and selected Revolved Ball Space. I selected the axis of revolution line, which is the center, And I'm just leaving it as a blind 360-degree revolve because I'm just trying to make a cylinder here. Now that I have the first component of the thermos body, I'm just going to file save as and saving this file as thermos body 2 since I already have a thermos body part file created. This is going to be very important when I move to create an assembly file to ensure that I have all of the correct part files ready to go for my new assembly. To open up the cylinder to create a shell type form that would hold liquid, I'm actually using the feature known as shell. And with shell, you select one or multiple faces to shell through. I'm only selecting the top face right now because I want the bottom face to maintain its presence in this model. So I've selected to show preview, and I can see that I'm going to shell a wall thickness of 0.25, and I want that shell to be inward, not outward. So jumping back over to the model that I'm creating, I'm going to Features, Shell, and I'm going to type in a thickness of 0.25 inches, selecting that top face, and then selecting Show Preview so I can ensure that it's actually shelling how I want it to shell. After that, I'm hitting OK, and you can see a perfectly shelled cylinder. So just to show that you can go back and edit features and sketches, I'm going back into the original revolved boss base sketch of the body, or also known as the cylinder. And I'm just going to edit the profile of the shape, just so you know that you don't have to build a perfectly symmetrical or perfectly cylindrical thermos, that you can actually go in and create more of a contour with the spline tool if you want to have more of an ergonomic feel to your thermos design. So this is just an example, kind of looks more like a vase than it does a thermos, but this is just showing you that you can also draw something more organic, that is more ergonomically friendly by just creating a sketch that has more curves as long as the contour of the sketch is closed. Next, I'm going to be building the top of the thermos body, and I'm actually going to not merge this piece but make it a separate piece, due to a couple of things that I'm going to be doing later on in the modeling process of the entire thermos. So going into that sketch, you can see that I have a dimensioned linear sketch here. Do notice the 0.13 dimension, that's a mess up, and I'll delete that a little bit later here. But that was from a previous drawing that I did, and I decided to change, and I didn't complete that entire line segment. It's just broken down into two components. So just looking at that sketch and looking at those dimensions, I'm going to move over to the new model and create a sketch on the front plane. And the reason I'm selecting the front plane is because I cannot select to create a sketch on a curved surface. So I'm dropping down that secondary design tree to select the front plane to sketch on. And that front plane actually intersects my initial revolved boss base because I drew that sketch on the front plane as well. So I'm quickly just sketching out the shape, the overall shape, and then I'll go in and add dimensions. Do notice that when I started the sketch that I did select the point all the way to the right at the top of the cylinder, so I did snap to a point. Now I'm just going through and dimensioning those really quickly so that they are the same as the original sketch on the left. And here is that dimension that I accidentally left in there. So disregard that. That really has nothing to do with the current model. Now I'm opening up the second revolved ball space that I've created for this model, and it's just called the body top. I labeled it. Again, with the axis of revolution, I'm going to select that center line, which is running down the center of the cylinder, and I'm leaving the direction as blind and the revolve at 360 degrees. However, I am unchecking that merge result because if I leave it checked, I'm going to have some issues later on in the modeling process and the threading process of this part. So when I move to KeyShot to render this part, that separation will not be noticed at all. So this is just for modeling purposes. I quickly want to show you how to edit your sketch plane just in case you drew that revolved ball space on the incorrect plane. So if you just right click your sketch and hover over Edit Sketch Plane, you can go in and actually change the plane or the surface that you drew on. So I drew on the correct plane, which is the front plane, so I'm just going to leave it at that. But I just wanted you to know how to quickly edit that sketch plane for future purposes. So next I'm going to go in and select to edit the second shell so you can see the details of that. And for this shell, I need to actually remove two faces, the top and the bottom face of the top component in the Thermos body. So over in my drawing, I've selected Features, Shell, and selecting that top face, and then I need to select that bottom face to be able to shell out that top component so that liquid can pour all the way through into the body of the thermos. But here I've gone and looked at this model in wireframe, and I'm selecting the face that I need, and I'm clicking to show preview, but it's not really showing the preview that I was expecting. So when I select OK, I get a rebuild error. I've left a few mess ups in this video just in case you come across the same issues. So what I'm doing here is actually hiding the body, which is the first revolved ball space that I created, so that I can select the proper faces to be deleted on the second shell. So I select the top, I select the bottom, and then I select to show preview, and I could see that this is exactly what I wanted. So now it's shelled all the way through, and by right clicking, I can go back and view those hidden bodies and bring them back into the modeling environment to show that the shell runs all the way through. Now I'm ready to create the thread on the thermos body, and just taking a look at the thread features, the details within it. You can see there are a lot of factors that go into creating threads, and sometimes you might have to play with these factors to be able to create proper threads. So the first thing that you have to do is select the thread location. So I have selected the top circle, and then you have to select an end condition, which I have selected the bottom circle to designate the location of the threads. the type of thread, the size of the thread, as well as thread method. Is it a right-handed thread? Is it a left-handed thread? And you can also select to trim the start and trim the end faces of the thread. So next I'm going to show you what all of that means. So going over to the model that I'm working on, I'm going to feature Hole Wizard thread. And if it prompts you this message about type and size profiles, just click OK. So now that I'm in there, I need to select the thread location, and I'm going to select the top circle, which is actually where I want the threading to begin. And then for the end condition, I'm going to select the bottom circle, which is where I want the threading to end. So I kind of get a little preview here of what that threading is going to look like. And it's already pre-populated the fact that I want to do an inch tap and the size of the thread. And I'm just showing you the profile of the thread here and where those two circles are that I selected. Again, I want to select the inch tap, and then I'm just going to drop this down so you can see there are a ton of different size threads. So it really depends on what type of thread you are creating. The threading method, I've chosen to extrude those threads compared to cutting them, and I'm selecting to trim the start and end faces so you can see what happened there. The thread no longer dips below the surface. So it looks like I have everything to go here. I'm going to select OK, and fingers crossed those threads have made. Next, I'm going to create a revolved cut. The reason for this is because I want the material that your hand actually touches to be kind of a rubbery, grippy material for the design. So first I'm going to cut out a place for that rubber material to inset into the thermos body. So just looking at that sketch that I created for the revolved cut, I'm using a center line, also known as a construction line, as what's going to be the axis of revolution for the revolved cut. The reason I want it to be a center line or a construction line is because I'm actually creating the closed contour closer to the outside of the thermos body, and I need that closed contour just to be thick enough to cut in a small groove into the body of the thermos. I'm also using a construction line just to get the center of the thermos body so that all of the cuts are symmetrical. And I'm using a center rectangle here to go off that center point so everything is equal on both sides. Next, I'm going through just to smart dimension those lines. So I don't really have the units set up properly in this model. I'd rather have more decimal points showing because it's rounding up that 0.0875 as 0.09, which is fine, but if I were building this for manufacturing, I want it to show the actual proper measurement, especially because this design would more than likely be either made out of metal or plastic. To create the revolved cut, I'm going to Features, Revolved Cut, not Revolved Boss Base. They're two different things under two different features. So moving on to the axis of revolution, I'm selecting that center line and I'm doing a blind 360-degree revolve and then selecting OK. Now to create the last revolved boss base, which is the rubbery material where the user's hand would go, I'm going to create another sketch on the front plane. And all I really need here is a center line that I'll use for the axis of revolution in this drawing. Now I'm selecting a corner rectangle instead of a center rectangle, and I'm going to draw the rectangle by snapping off that corner ledge and bringing out that rectangle just a bit so then I can smart dimension to the proper measurements. Now I'm going back to look at that last revolve just to show you the details of it. Remember, this is a revolved boss base and not a revolved cut. I'm using the center line as the axis of revolution, and I'm ensuring that that merge entities option is deselected. Next, I'm moving to the fillet feature just to show you what those fillets look like in the model I've already created. And moving over to the model I'm working on, I'm going to select Features, Fillet, and then I need to select edges or faces that I want to fillet. So I want to fillet that bottom edge, and I'm looking at the full preview. Set that at 0.125 inches, and then I'm just going to move forward and complete the remainder of the fillets. There's also a chamfer option that gives you a nice angled edge, but I'm going to do fillet 2, and it pre-populated everything to the same as the first fillet, which was nice. I didn't have to do anything but select OK. And then for the third fillet, I'm actually going to select the entire face of the feature so that it fillets both edges at the same time. So going over to fillet, I'm just going to select that solid surface, and it grabs those two edges. Zoom in here. You should be able to see the little tiny fillet. Lastly, I'm just going to color code the components of this part so it makes it a little easier to identify the components once I move to the assembly, especially when I'm trying to match up the threads. So I've selected to just drop a color on the features. And when I go into dropping the color on there, I do have to deselect the entire thermos body because that's what it pre-populates with. So I select the feature option, and I can drop down the design tree and see the different features, or I can select them just through the interface. And for the threading material, I am choosing the matte steel option just so it looks correct, like metal. So the body of the thermos is yellow. I do have to select those fillets individually because they are separate features. The internal components are yellow. The rubbery material for your hand is green. And just to reiterate, the screw threads are a matte metal. And one thing I forgot here are those tiny little fillets that I just made. Oops. And I have to go in and select that separately. This is the lid component that I'll be creating for the Thermos design, and here I'm just rolling back the features so that I can start from the top for you guys. So I'm starting a new part here. And I'm opening up the Extrude Boss Base sketch so that you can see how I drew the beginning of the circular component. The interior circle is 2.5 inches and the exterior circle is 0.25 inches offset from the interior circle. Here I'm just drawing a circle and then I'm drawing the interior circle, and I need to reset the units to IPS. And I'm going to go back and smart dimension the interior circle to 2.5 inches. Now I'm smart dimensioning the distance between the interior and the exterior circle to 0.25 inches. Now I'm opening up the extruded boss base and just checking out what that distance dimension is, which is 0.5 inches. Now going back to the model that I'm working on, I've select features, extruded boss base, and I'm going to be extruding the parameter of the circle of the lid, and I set that to 0.5 inches. Now that I have my model going, I'm going in here and saving this part as Thermos Lid 2. Next, I'm rolling back down to reveal the thread feature, and I'm going in here to check out what those properties are so you can see. This is where you may need to play with your model a bit if you're recreating threads like this. So I'm moving to the model that I'm working on. I'm going to Hole Wizard Thread. And if you get this, just click OK. The first thing I need to do is to select the first thread location, which is going to be that top circle. And I'm putting this thread on the interior since it covers the exterior of the thermos body. And the next thing is to set up that in condition edge, which is the bottom interior circle. I'm going to select to offset this, and I'm going to reverse the direction so that it does stop itself in place and doesn't continue to thread on once the bottle cap is tight. I've selected to extrude the thread. It pre-populated the type inch tap and the size of 4, so that matches the size and type of my other thread. It is a right-handed thread, and I am trimming with the start and end faces. So I selected OK, and it's given me a rebuild error. And just looking back at my previous model, the Thermos body, I realize I need to select cut thread and not extrude thread. Now I'm going back to the other model, and I'm going to drop down the extruded boss base so you can see those details. This feature is the top cap to the lid to seal it from any liquids escaping. So going into that sketch, you can see I just converted the line of the circle already in existence and extruded that. Now I'm going to create a sketch on that top surface in the model that I'm working on. And I'm going to select that top surface again until it turns blue, and then select Convert Entities. And that is going to convert that exterior top circle of the threaded component to a line. So I don't have to redraw that line at all. I can just select a surface and select Convert Entities. Now I'm going into the extruded boss base just to check out those dimensions really quickly, and then going back to Features, Extruded Boss Base, and typing in 0.25 as the extrusion, and ensuring that that merge result is not checked. So the last two things I have to do in terms of modeling for this part is to put the fillets on the cap. So I'm just going in there to check both of them since fillets are pretty easy, just checking those dimensions. So finally I'm going to Features, Fillet, selecting that top circular edge. It pre-populated to 0.125 inches, which is what I wanted, and then selecting that bottom edge as well. Now I want to color code this lid part so that I can differentiate the two parts and where they connect or where they mate within the assembly that I'm about to create. So I'm just going in here and clearing all selections, then selecting the option to select only features. I'm selecting the thread first. Gonna go ahead and put that matte steel on the threading. Then I'm going back in, clearing that thermos again, the whole model, and then selecting to select features. And I'm going to get the boss base extrusion, and the two fillets, and color them yellow. So now my models are ready to move into the assembly portion. So to begin the assembly, I'm looking at the two part files that I'll be bringing into the assembly file. So the names of these are Thermos Body 2 and Thermos Lid 2. I'm opening up the previous assembly that I've created as an example. So this one's just named Thermos. This is what my final product looks like and how it functions. So minimizing that, moving back to the two part files that I just created for this tutorial, and I'm going to go to File, Make Assembly from Part. This brings me to the Insert Components Property Manager, and I have pinned down this property manager so I can insert both components, and you'll see the old Thermos assembly also shows up here. And the first one that I placed was the Thermos body, so it is fixed, and the lid should still move about since it's the second one that I placed. I'm going to File, Save As, and I'm saving this assembly file as Thermos 2. And you want to make sure that if you're doing this tutorial that you save it as an assembly file and not a part file. Next, I'm going to make the concentric mate to start putting this assembly file together so that the threads will work properly. So just dropping down so you can see the detail of the mates. I'm creating the concentric mate first, and I have to select two corresponding circles that are in line with one another so that the lid stays in line with the thermos body in a concentric relationship. So going over to the model that I'm working on, I have selected mate, and I'm going to select concentric and then click on a circular line on the body of the thermos as well as on the lid of the thermos. It really doesn't matter which one of the circles you choose. It's going to create a concentric mate. Now later on in this model, I'm going to go ahead and warn you that I have to redo the concentric mate a few times because of things getting in the way and having to hide parts to get the other mates to work properly. So this concentric mate is temporary. Here, I'm just double checking to ensure that the circles did create a concentric mate and that the lid and the body of the thermos line up properly. So to be able to do the limited distant mate, I have realized at this point that I need to go into Thermos Body 2 and remove the fillets. So I've rolled back the fillet features and I'm getting some error messages. So I just click close on those, and I'm going to open up the Thermos Lid 2 part and remove those fillets as well, which my main concern is that bottom fillet so it matches properly to the body. So now I'm going in to edit the concentric mate because I had clicked on circle lines that were attached to the fillets, And so now I'm going back in there to click on the circle segment lines that are part of the body and the lid minus the fillets. So once I get that back in order and click OK, everything looks good. And now I should be able to move to that limited distant mate. If you ever get the rebuild error, it's always good to just click rebuild so that it removes any issues. So now I'm going to the limited distant mate of the model I've already built to look at the distance, which is 1/2 inch, 0.5 inches, and to see that the maximum amount of distance that I want to create is 1/2 inch, and the minimum I want to set at 0. And you can see that I've selected the bottom line of the lid and the top line of the body. So moving over to the thermos that I'm working on, I'm going to go in and edit the distant mate that I have created. I accidentally selected regular distant mate when I should have went to the advanced mate options, which is here. And again, just to reiterate that I did click on that bottom circle line of the lid and selected the distant mate, and I set that at 0.5. I set the maximum at 0.5 and the minimum at 0. So now there's a distance restraint, meaning that the lid only moves 1/2 inch up from that body. I've now opened up the screw mate in the model that's already completed to show that I have to select 2 different mate options, one on the lid and one on the body. And I will be doing a screw mate. So I'm just going to maximize this so you can see it better. And I'm choosing a wireframe with some hidden lines in there so that I can line up the screws properly before I try to complete the mate. So I just need to kind of eyeball these. It's good to zoom in really close to get them as perfect as possible so that they move properly, especially if you're going to create a simulation of this. So zooming in, it seems like I've got them aligned pretty close so that it would work. If I were doing this for manufacturing, I'd probably take a little more time here to ensure that it is aligned as best as possible, especially if I plan on 3D printing this. So I've got them aligned, and I'm moving back to being able to see the entire solid and creating a section view that splits the thermos design in half, and so that I can see that the threading is aligned properly and to be able to select the lines that I need for the screw mate. So next I'm going to mate, mechanical mates, and then I'm selecting screw. And I just want it to have 1 revolution, and I'm selecting the interior of the thread on the body and the exterior of the thread on the lid. So that's interior thread on the body, exterior thread on the lid. And then clicking OK. So once I've done that, I should be able to move that lid and it run along the threads with little to no interference. I do have some alignment issues there that I really need to go back and fix. But for this tutorial, I'm just trying to get the point across of how to create the screw mate. So you can see there's a little bit of an alignment issue here, but that's okay. So removing the section view, you should be able to see that the lid moves up and down along the threads without interference or collision. Now I'm going back and opening up the Thermos Body 2 and Thermos Lid 2 so that I can roll back down those features and let those fillets reapply themselves. If you're doing this, be sure that you save after you reinsert those fillets, or else it may not show up over in your assembly file, and obviously you need to select to save and rebuild. So one of the reasons I was getting that error down at the bottom right is because I have too many things open right now on my computer, and having all of those part files in that assembly file open at once, it's causing some memory issues. So if you get that on your own computers, you may need to go through there and close out extra part files or close out other large programs that you're using at the same time. And lastly, everything is working properly, but I really do need to go back in and edit that concentric mate. So one more time, going in, editing the mate. Now that the fillets are back, it's showing an issue. So I'm just clearing those selections and then reselecting those original fillet circles so that the mate does stay concentric when it's moved. So instead of the fillet circles, I'm selecting the top circle and the bottom circle just to make them concentric, to show you that you don't have to choose circles that are closest to one another.